This is section 3.3, power functions and polynomial functions. In this video, we're going to go through number 37 in your book, and this problem is asking us to identify the possible function with the least number of degrees that could be this graph. Alright, so if you remember earlier in this section, they gave us a golden rule of finding the least degree polynomial, and it told us that a polynomial of degree n will have at most n number of x-intercepts and n minus 1 number of turning points. So to determine what the least possible degree is of this function, we're going to find our number of x-intercepts and our number of turning points, compare them, and determine what our least possible degree is. So looking at this graph, I see that I only have one x-intercept here. Only crosses the x-axis once. So number of x-intercepts is 1, which tells me that our degree must be at least n. Well, it's probably going to be more than 1 because there's a lot going on in this graph. So let's go ahead and move on to turning points. Number of turning points is just wherever the graph turns from going to increasing to decreasing or vice versa. So I see that from here it's going from increasing to decreasing. So here's one turning point. Here it changes again, second turning point. Here's a third turning point, and here's a fourth turning point. So that means that I have 4 turning points. Relating this to my original function, I know that n minus 1 equals my turning points. So if n minus 1 equals 4, that means that my n, my smallest possible n, must be 5. So comparing these two values, I know that n must be at least 1, and based off my x-intercepts, and based off my number of turning points, I know n must be at least 5. Which means that I'll have to take this as my least possible degree of this function. So remember, brief recap, how to determine the least possible degree of this polynomial. First, we look at the number of x-intercepts, and then the number of turning points, and then we had to compare these two values to see which one represented the least possible degree of this function. I hope you found this video super helpful. The concepts covered in this video are true no matter what pre-cal class you're in, but in case you're interested, all the sections and problem numbers referenced in this video came from this lovely textbook right here. Remember that if you're a Baylor student, we offer free tutoring on the first floor of Sid Rich at our Success Center. You can either schedule an appointment online or drop in during our business hours for free tutoring in pre-cal, calculus, and a whole lot of other subjects as well. For more information, visit our website.